our next question is path with the maximum probability. So the question state that you are given a, let me zoom first. You are given a undirected weighted graph of n node 0 indexed, means 0 to n minus 1, represented by an edge list where edge I equal to a comma b is undirected graph, means we can travel in the both direction, connecting the nodes A and B with the probability of success of traversing the edge success prob I. So given to node start and end, we have to find the path of the maximum probability of the success to from start to end, return the success probability. So if there are no path, return 0. So we have to return the probability for traversing the start node to end node. Like in this example, we have given start from example number 1. So this is example number 1. So like in this example, you can see we have given 3 nodes and edges are given, means there are edge between 0 comma 1, there are edge between 1 comma 2, there are edge between 0 comma 2, and its success probability means for each edge, means for this edge success probability given this, for this edge given this, for this edge given this. So we have also given the success probability for each edge. So we have to go from start 0 to 0, means we have to find, means from this node to this node, what is the maximum path we cover with the maximum success probability. So success probability is defined as we go from like one path to another path, means one S to another S, then S will be multiply, means S will be multiply. Like from 0 to 2, how many paths we can go? Either we can go from 0 to 1, then we can go 0 to 2. Otherwise, we can go 0 to 2 directly. So, what will the maximum probability? So, first we go to 0 to 1, then probability is 0.5. Then we go to the 1 to 2, probability is 0.5. So, total probability with its multiplication means 0.25. Then another path is 0 to 2. So probability is 0.2. So what is the maximum? So 0.25 is maximum. So we will return 0.25. In another example, if we see like probability is 0.5, 0.5 and another is 0.3. So its total probability means for this path probability will be 0.25 and for this path probability is 3. So 3 is greater than, means 0.3. So 0.3 is greater than 0.25. So we will return 0.3. Otherwise, if there are no path, means the we cannot go to the 0. We cannot go to the 0 to 2 because there are no path. So we will return 0. So we will return a double value. Means we have to return a double value. So the question is how we will solve this problem. So we will solve this problem by the Bellman-Ford algorithm. We will solve this problem by the Bellman-Ford algorithm, means shortest path to all the nodes from single node. So in this algorithm, we do not have to do multiple things. Means in the extra algorithm, we have to traverse to each node one by one, find the minimum path. But in this algorithm, we will create our distance matrix. Like in this graph, there are three values: 0, 1, 2. Initially, we will set its value with maximum value. We have to find the minimum path, so we will set the value to maximum value. Then for each edge, means for each edge we will make a relaxation. So what is the relaxation? Means if weight of u plus, means sorry, not weight, distance of u plus our weight is greater than distance of v, then we will make distance of v equal to distance of u plus our weight. So this is relaxation we make for the each edge. But in this case, if you see, we have to find the maximum. In the previous we find the minimum, but in this case we have to find the maximum. So what we will do, like we have to find the probability. So means like we have node 1 and we have node 2. It can also say node u and node v. Its current probability like 0.5, its current probability is 0.2, and its path probability is 0.5. So what we will do, we will check that if means probability of u into our this probability, let's assume is cu prob, if it is greater than, if it is greater than our probability of v, then we will set probability of v equal to probability of u plus our current probability. In our example, I have made a mistake, like it will be the minimum. Means if we have to find the minimum path, so it will be the minimum. In our this question case, we have to find the maximum probability. So we will find the maximum probability like this. But those element was the directed on the directed graph, on the directed graph. But in this case, we have undirected graph, so we will make this approach for u, means like we can go u to v as well as we can go v to u. So we will make relaxation for both the edges. So this will be our problem will be solved. So this is very simple approach we are solving this problem. Like if we solve our problem for this array, let's try run our code. Before that, first we see the what is the code for that. Then we see that we see that we created a double max probability array that will store the probability for the each nodes. Then we will initialize the value with the 1, means its maximum value will be 1 and minimum value will be 0. Then for n minus 1 times we made the relaxation for n minus 1 times, and we set a variable each change, because like value, our current value is 0 1 1, our current value is 0 1 1. If we made a relaxation and our value is not changed, if our value is not changed for one relaxation, then it does not mean to do again and again, means n minus 1 time. So we set a variable each change. If it is false, then initialize with the false, then we will check. If any condition satisfy, then we will set it true. And in the last, if it is false, then we will return, means there are no changes done in our maximum prob. So we will return, otherwise we will update it. So what we will do? We will get the edge, means we will get the u and v. First node is U and second node is V, and our current prob, what is the success probability for the current node. Then we will check that maximum probability of U into current prob is greater than, means we do the relaxation for path U to V, then we do the relaxation for path V to U. So in this process, after solving this problem, we will return the maximum probability of the end node. So this is our solution.